Hello, this presentation is for ICASSP 2023. I'm Shoichi Koyama from the National Institute of Informatics, Japan. The title of this presentation is Spatial Active Noise Control based on Noise Field Interpolation from Reference Microphone Signals. Environmental noise is still an unsolved problem and affects human health significantly. Active noise control, ANC, is aimed at cancelling noise by using loudspeaker signals, but its effect is limited to a local region. We here address spatial ANC problem, which is aimed at cancelling noise over the spatial region by using multiple loudspeakers, as shown in this figure. We previously proposed a spatial ANC method based on kernel interpolation of the sound field. So this is a schematic diagram of the spatial ANC. The incoming primary noise is captured by reference and error microphones, and the loudspeaker output to suppress the noise over the target region omega is computed. In the conventional multi-channel ANC, the cost function is typically defined as the power of the error microphone signals. So, the noise reduction is achieved only around the error microphones. In the spatial ANC, the cost function is defined as the regional integration of the noise power over the target region. But it is obvious that the sound field UE here is unknown. So we applied kernel interpolation of the sound field to estimate this UE from the error microphone signals. Then the optimal filter W, which is used to compute the loudspeaker driving signals from the reference microphone signals, is adaptively obtained. Thus, the regional noise reduction can be achieved by this kernel interpolation-based spatial ANC. But the issue is that many error microphones are still required for accurate estimation of the sound field. Since ANC users will present in the target region, it is preferable that the number of error microphones is as small as possible. So we here propose a spatial ANC method based on kernel interpolation of the sound field from the reference microphones instead of the error microphones. It is required to increase the number of reference microphones, but we can save space for ANC users by reducing the number of error microphones because the reference microphones are normally placed outside the target region. We proposed two approaches to spatial ANC based on kernel interpolation from the reference microphones. The first one is based on the fixed filter derived by estimating the primary and secondary sound fields independently. In this approach, we formulated the fixed filter, as shown in this equation, and these matrices AYY and AYX can be calculated by using the kernel interpolation filter and vector of the secondary path. So error microphones are not necessary in this approach. The second approach is a combination of the fixed filter and conventional multi-channel NLMS. The cost function is defined as the time-varying weighted sum of the regional noise power and power of the error microphones. And here gamma is the forgetting factor. Then the control filter transitions from the fixed filter W fixed to the control filter of the multi-channel NLMS. We show some experimental results. So a circular target region is set as shown in this figure, which contains a rigid circular object. This is because our proposed method mitigates the scattering effects inside the target region by interpolating the sound field from the reference microphones. And 12 secondary sources, 2 error microphones, and 6 reference microphones are set like this. We compared the conventional NLMS, proposed fixed filter, and NLMS transitioning from fixed KL. The results indicated the NLMS with fixed KIL achieved the largest noise reduction at all the frequencies, as shown in the left figure. The right figures show the power distributions of each method at 400 Hz. Here are the conclusions. We proposed a spatial ANC method based on kernel interpolation from reference microphones to reduce the number of error microphones and save space for ANC users. We proposed 2 approaches based on kernel interpolation of the sound field, and the largest regional noise reduction is achieved by NLMS with fixed filter. So, thank you for your attention.